A clock is routed to a flip-flop through a 154 micrometer long wire, so this is going to be a length, and it's found to have a delay of 13.3 picoseconds, so this is a delay. If the same wire continues to connect to a second flip-flop, so we'll go from the first flip-flop to the second flip-flop, we are asked what is the maximum distance it can go in microns before the clock skew exceeds 129 picoseconds. And so we have all this information here, and now all we need to do is solve for it. So clock skew is also going to be, we'll treat it as a delay here. And so we know that we have a clock. It's going to look like this, and it goes to a D flip-flop. We have two D flip-flops, so we have our data in, and then we have our clock, and then we have our output, but we don't need to worry about that here. We also have another one over here. So output, data in, and then our clock. So this clock is going to go to here and to here. Now there's going to be some delay from this, some delay from this. There's a length here and a length here, and we need to find the maximum distance in microns it can go before the clock skew. So the delay, the clock skew, the delay of this one becomes greater than the 129 picoseconds that we've afforded it. So now to solve this, we'll call this as like step 1, drawing it out. Step 2, which is the math portion, is just we're essentially setting our length 2 equal to distance, or the delay 2, and it's going to be over length 1. So you have delay 2 over delay 1 like this. Now they don't go through this linearly. Delay through a wire, it increases proportionally to the wired squared. So that means that our length in the wired has to be squared for both of these, and that's going to be equal to the delay. So delay is the squared of our length is squared of the of what it has, because how it increases proportional to delay. So from here we can just plug things in. We're solving for L2 here. So before we plug anything in, actually, what we can do is rewrite this. We want to solve for L2, right? Because we're asked what's the maximum distance. If your problem's a little bit different, there might be a video on that, or you can just rearrange this equation to solve what you're looking for. If it's like a skew, you might be looking for D2. So L2 is going to be equal to the square root of our D2 over our D1 times our L1 squared. So for my problem, when I plug in my values, we're going to have L2 squared, or L2 is equal to the square root. Our distance 2 is just going to be delay 2 is just going to be 129 picoseconds. So 129p, and then this is divided by our 13.3 picoseconds. So we'll have 13.3 picos, and then this is being multiplied by our L12, which is simply 154, and then it's a micro, and this is going to be squared. Now, to save yourself some time, the picos can cancel out, and you can plug all of this into a calculator, and you're going to get the L2, the length of the wire is going to be 479.6. So that's how we would solve it given these variables. Variables are different, you just plug them in, and if you're looking for like the clock skew, which is this 129 right here, you would just rearrange the problem. But there will be a video on that or something similar. And that's how I would go about solving this problem.